Hello, everyone. My name is Rimeike, and I'm the founder of Quantum Cybersecurity Skills. Today with me is Kareem El-safty. And Kareem, maybe you can introduce yourself.
Oh, sure. Thank you. Thank you so much for this. First of all, I am Kareem Safti. I'm a research assistant at Wigner Research Center for Physics in Hungary. I'm also an AI engineer in DevisionX in Egypt. Uh, my journey to quantum computing actually started way back when I was a bit younger. I was fond of physics, and I wanted to do a physics degree when I grow up, but I ended up doing engineering school, actually communications and electronics.
Mhm.
And then out of out of the blue, I started doing machine learning at my final year. My graduation project was based on machine learning for voice recognition and object detection.
Wow. Mhm.
Yeah, and after that, I decided to pursue this career as a machine learning engineer. And after that, I decided to go deeper and deeper and explore the deep learning algorithms and everything related to it. And finally, I started to merge quantum computing with machine learning, and I ended up with quantum machine learning. So that would be like the bottom
And
line of the
and
story.
tell me, please, what was your specific, why you were captured by quantum and machine learning? What value did you see? Because no, I mean, people don't invest their time and education in something that is not going to benefit a bigger picture,
Mhm.
right? So
Yeah.
just curious, how did you make, at what point and how did you make that decision where you said,
Okay.
aha, this is a new big wave?
Okay. Before that big wave, um, the physics thing, or the or my fond of physics itself was like centered around what is time traveling and how to build time machines. I was very young at that age, or that moment. And then I started to read about Einstein theory. I mean, the special relativity and the general relativity, and the conflict between these two theories with quantum mechanics and the singularities that we end up with. So that was like around high school, and I, I was just thinking about quantum physics, and that's it. Nothing about quantum computing at all. But after doing my engineering degree and started to learn more about classical computing, or the fundamental theorem of classical computing in general, what is programming and digital design or digital thinking itself,
Mhm.
then I started to say, okay, there is this path of quantum computing. Perhaps you can merge this engineering knowledge that you are currently building with your own passion, and that is the starting point. Regarding the machine learning thing, when I was at my final year, I realized that I don't like communications and electronics a lot. I mean, the career itself, it's pretty much rewarding. I mean, the money and everything about it, but it was not my interest at all. Okay,
Mhm.
so I said that machine learning is quite interesting, and it's also relatively new in Egypt. So I think it would be a better path for me, and it would be also great for me to pursue something like quantum machine learning, because at the end, uh, using the quantum characteristics of computation, or using the characteristics of quantum mechanics in the computation in general, always leverage the classical computation. I mean, it always surpasses the classical computation. So
Yeah.
why not machine learning? So that was my thing. The click.
I've been reading. Uh,
Oh, proper.
yes,
Yeah.
it's more like
Mhm.
tango with
Yeah.
with qubits. You know,
Yeah.
it's very
Mhm.
intense.
Yeah. I have this book, but like the electronic version of it.
All right, and
Yeah.
another one,
Yeah,
which
Jack.
is
Yes,
a little bit of wow.
yeah. He's. I
Let's
think
dive
he's
deep into this.
the circ. He's from Google, I think. I think, and the book is written with circ exercises, I believe. Yeah, so yeah, that is the one. Yeah. Mhm.
Yeah. No, it's good. So let's touch upon our second question, because the introduction went into the first question about your journey, right?
Yeah.
So second question is, so what would you advise to the organizations who are keen on benefiting from quantum computing? What skills they need to be looking at? How could they nurture those skills? Can they
Mhm.
nurture the skills internally? Do they need to hire external expertise, to benefit maximum from quantum computing, be it in financial sector? Pharma I see is accelerating like crazy. Yeah, so what would be your advice, be technical and non-technical skills? Maybe, what
Okay.
makes the quantum computing happen internally in the organizations?
Okay, let's start with the non-technical skills because I do believe that they are very, very important. Regarding the non-technical skills, uh, the candidates should at least have like a great way of communication with others. He should be able, or she should be able, to communicate their visions and their minds about their findings, and how to make it very simple and very clear with everyone else, because not, I mean, everybody is not interested in the details of quantum mechanics or quantum computing because they are always hard. That is one of the most important things. The second most important thing about the non-technical skills, I do believe it would be to be able to always push yourself to the boundaries and learn everything from scratch with your own hands and your own mind. So you should always be ready to learn from everyone at every moment, whether young or old. So self-learning or self-teaching is very
I think
important.
it involves also a lot of perseverance, right?
Yeah, of
And
course,
a
and
lot
a
of
lot of patience.
grittiness. We
Yeah,
all have
patience.
different levels of patience to
Mhm.
get the results, right?
Yeah, that is correct. So the third thing would be to be able to accept criticism, because at the end, every experiment you do could be a big failure, but at the end, it will lead you to a great or a huge success. So it is totally okay to accept your failures and say that I failed. That is completely normal. So these three non-technical skills are very important, and they should carefully look at them. Regarding the technical skills, so depending on the level of maturity, I do believe that at least a master's degree, okay, in a related field is very important. So that is one of the most important things, and not just like okay, I wrote a thesis, or I can do some codes, or something like this, but no, like a strong publication record. And if the candidate does not have a master's degree, at least he can show his own skills. I mean, he can show off a bit about what he knows or she knows. What else? For example, the GitHub profile, or a great portfolio, or a good publication record. It doesn't mean that you published a lot. Also, it's not like a great thing. The most important thing is about the ideas that you invested your time in, and how you can show them. I mean, or to present them correctly and beautifully. So that is one of the most important things. Uh, and depending on the required job itself, it could be ranging from great experience in programming or great experience in experimental physics. So
Any specific language? Is it Python mostly, or is it any
uh,
other?
well, Python and C++, the
Okay.
two are very important. And also if there is someone who is also good at GPU programming, that would be fantastic, because at the end you would like your simulations to be very fast. Python is great. It facilitates everything, but it's not fast, and that is a problem. So C++ knowledge is handy at this situation.
Okay. And, you know, I experimented myself with the IBM Q experience. You know, I'm a part of Qiskit, you know,
Qiskit Advocate. I'm also a
on
Qiskit
on
Advocate.
Slack. You
Mhm.
know, some again, are they compared to the knowledge people usually have, like programmers with those programming language skills? Is it a lot of rewriting the way you think when you do the quantum, when you create quantum algorithms? Is it a lot of, is it massively different, need different angles of thinking, or the transition is you know, doable, let's put this word?
So um, I didn't quite understand your question. So
Uh,
are you asking about the transition between classical implementation and the
yeah,
quantum implementation?
yeah, correct, yes.
Okay, let me tell you this. In Egypt, I fully work as like simple machine learning engineer. I just simply use the tools that everyone uses. For example, like TensorFlow, PyTorch, or sometimes MixNet. So I'm just thinking about implementing the algorithm, and that's it. And in some situations, I am required to build the package and then deliver it to the software team. So just the simple standards of code or coding or software engineering. Regarding my work at Wigner Research Center, uh, I just apply the same software rules or mechanisms, and that's it. But I'm just thinking differently about how should the mathematics work with the software itself. So I do think that the transition itself is not that hard, but it should be clear for anyone that is interested in quantum computing to be able to do the switch like easily. It's not a big deal, and it's not that hard. At the end, you are following the same rules of software engineering, and that's it. But it is only the switch between okay, I'm for example, I'm building like a linear model for classifying linear data, and then at that I mean, on the other side, I'm just building a quantum circuit from scratch to optimize it, and that's it. So I'm not thinking that it's a great transition, just a simple transition, and the same software tool. I mean, the same software rules. So it's not a big deal.
Okay, fantastic. Thank you.
Yeah.
That's very insightful. And our last question we aligned to touch upon was, you know, you have quantum AI expertise.
I'm not taking this one.
You know the principles of quantum, right? Quantum
Yeah.
computing.
Hmm.
How do you think this could potentially impact cybersecurity? And I mean more from resilience, from defense side. I'm not talking about like cryptography, right? Encryption, I mean, but more from operational side of cybersecurity.
Uh-huh.
Um, so when I'm reading, you know, many books on quantum, to me, it's just my vision. There are opportunities open in threat modeling, in
Hmm.
incident response as well, better predictions, you know, by leveraging quantum AI. But I'm very curious, what would be your insights? How do you see impact, you know? Again, I think organizations would be very interested to hear.
Sure. Okay, this is a bit of question, but let me tell you, for example, my first my feeling. Okay, that would be like totally my own opinion, and then we will dissect everything into small chunks, and I will try to put it like a very technical answer to this. Well, for example, I'm building a quantum circuit to do something called QAOA. It's a like an optimization problem, and sometimes this circuit requires a lot of 2-qubit gates or CNOTs to achieve some requirements of minimization, for example, or approximation to the classical solution or to the optimum solution. So at the end, when you run this circuit, I mean, it's fantastic. You can do a lot of things with QAOA, but at the end, uh, for now, you cannot run it completely healthy on a quantum system. So if you have like 5 qubits and then the depth of the quantum circuit is more than, for example, 16 or 32, then most of the available quantum computers on the internet, I mean, like the available ones, IBM, uh, the output probability will not be great for you. It will be very bad, and simply enough, it could be like white noise. So, so when we are talking about like a real threat from a quantum computer to cybersecurity in the near future, I mean, like in the upcoming 5 years, it wouldn't be very realistic. Let's be honest about this. It won't be very realistic. But in the long run, or in the long run, like let's say like 20 years from now, that would be a risk. There will be a risk because most of the classical computers right now, or we are pushing the limits on the classical computers right now to keep up with the quantum advantage that, for example, Google has achieved like lately, and then IBM tried to say that no, we can do it, but at the end, IBM made it like I think I don't remember the correct time, but I think like in 3 days, and Google did it like in 2 hours or 3 hours. So there is still a huge gap or a huge time between them. But at the end, the classical computer actually made it there. So I think we should be very skeptical about the quantum computer itself, but we should think about the classical computation right now, or the potential of the classical computation right now. So there is something called quantum post resistance, okay, or quantum resistance. So working on quantum resistance algorithms is crucial and also very important in the far future, but it is very crucial to do it. So that is like my own opinion regarding the powerfulness of, for example, like quantum machine learning. Uh, there are a lot of papers lately that talks about the expressibility and trainability of quantum variational circuits and quantum neural networks in general. And it says that it's okay, you can actually have like a lot of qubits, but at the end, you will end up with some bad local minimas, and that is a huge thing, or a huge or a very terrible thing. It is called the pairing plateau. So there is also a trade-off between the expressibility that you need and also the required accuracy, or the required minima that you actually want to reach.
Yeah.
So when we are talking about leveraging the accuracy of classical models, we should be very skeptical about whether or not quantum can actually achieve or boost classical algorithms. We should be very careful about this. I know that my views may be a bit pessimistic, but I'm trying to be as much as possible to be technical enough and also be realistic about what we have right now. It's okay that, yes, quantum variational circuits does have or do have a lot of expressibility. That is correct. Okay, but how can we actually use it, or how can we put it in a position that actually push the limits of classical computing or the accuracies of the current state of the art deep learning methods, that is still an open question, and we should that is something that we should actually focus on, how to use the current findings. I mean about the expressibility of quantum neural networks to push uh, the current state of the art deep learning algorithms. Another thing here is that there's also something called tensor networks, and tensor networks, they are simply like a smaller version of a huge neural network. They are simply like we are contracting everything. So that is also another point of view of computation, and another point of view of thinking about the advantage here. So we are trying to minimize the resources, and at the same time we are achieving the same results. That is very important for the embedded sector. I mean the embedded device sector. For example, a lot of factories tries to or yeah a lot of factories try to implement deep learning solutions on their sites or on premises. So using embedded devices to run huge neural networks, it would be great to quantize the models using, for example, tensor networks. That is great. For example, if we can achieve the same accuracy of a huge neural network with a small quantum neural network, then that would be also great. But at the end, we want it to be fast. So again, as I told you before, C++ is a great way to achieve high speed. Okay, and Python is a great way to experiment and to do fast prototyping. So
Yeah, I'm reading
that
that
will be my answer.
there is a lot of scientific work, where quantum results are being sort of tested in parallel to the computers we have for the accuracy. Can we trust and so on. I'm also reading a lot about leveraging quantum on still being able to leverage it on existing infrastructures, not sort of hybrid, but it doesn't need infrastructure doesn't need to be built from the scratch. Can you comment on this, maybe just to give some organizations an idea how this could be achieved?
So are you asking about how to integrate the current infrastructure with a cloud
Yeah, what
computing
are the
engine?
ways exactly to benefit from quantum in existing infrastructure? Yeah.
Okay. I believe that let's take D-Wave for example. D-Wave at the beginning they used to deploy their own hardware at like a specific site. Okay, that was like their old model or their old business model. But for now, they are using their cloud, and they are dedicating like their service or their quantum hardware as a software as a service. So I think the integration at that level would be great. That is the first thing. The second thing is that I I don't think and or I do believe that you should also check this information. Perhaps I might be wrong on this one. There is a company called Zapata Computing. They are also building like a software layer between the classical software and also the quantum hardware. So they are trying to integrate the two or both of the infrastructures together. So that would be a great level of integration, because at the end there are lots of levels between. Okay, we have two different hardwares, then there is another layer of software, there is another layer of another software. So it would be great that there is a company like Zapata Computing to do that. um, what else? Yeah, the IPM Q1, I think, or Quantum one. Their system, like in 2020, they said that instead of being like on lab, they can actually let their own quantum computing be deployed like in another part of the world. So that would be very interesting. I don't know if they actually did that, but for now there is this IPMQ network that has a lot of Q partners, and they are using their the IPM infrastructure for quantum computing, like with the high privileges and also premium devices. So I think the companies right now should be very interested in investing in this, and
Yes,
also rapidly.
there is investments are almost daily, all over the news. This organization or that is collaborating with the many providers of
Mhm.
quantum computing. So yeah, and
Yeah.
it's gonna
And
accelerate.
I think also in Netherlands, I think two Delft University has its own quantum centers and also their own quantum network center. I mean quantum network devices. You know, they are building some of the most important quantum cryptographic systems, I believe. So
I read it.
yeah. So they are very interesting. So
Yeah, China is driving
yes,
quantum communications. I
in the
read
space.
about
Mhm,
quantum networks in many places of the world is getting crazy. Although, as you say, there
mhm.
is an argument. Well, most articles do agree. Next 5 years is investment without massive benefits, but it's worth investing because it's
On the
expectation
long
is
run,
gonna
yeah.
accelerate after, proning to errors will be more manageable or completely removed. But yeah, and
By the
and
way,
plus, the physical elements of
mhm,
quantum temperature, stability, you name it, which are causing those errors.
mhm. And
No,
by the
it's
way,
it's been my
in
pleasure,
classical
Kareem.
computing,
I'm sorry?
mhm, I mean, in classical computing, I mean, like in the early stage of classical computing, let's say that like in the 60s or the 70s, uh, error correction is not like done on a very small level on classical computing, but on many different levels. So for example, when I open the calculator program on my Windows or Linux or any operating system, and type like 3 multiplied by 3, it's simply 9. So that program actually is run on like so many different levels of error corrections. So the classical computing took a lot of time to reach this stability, and it is totally natural for the quantum computing to take its time to evolve. But let's say something here, it is evolving very fast, even faster than classical computing back in the day, like back in the 50s and 60s.
Yeah, yeah. I especially admire, you can see in my logo, 0 and 1 being at
Yeah.
the same time.
Yeah.
Brilliant. No, Kareem, my pleasure. It's
Thank
been
you.
fantastic
Thank
to
you so
have
much.
you opening your knowledge, your mind to organizations who will be listening into it, capturing for new ideas, making organizations think for the next potential step into quantum. My pleasure. Thank you, Kareem.
It's my pleasure too. Thank you. Thank you.